Now that you've listened to the first part of 9.2 and worked an example, hopefully without your notes, we need to finish this very short section, and I'm on page 487. I do want to read some pieces to you, and then we'll work an example together. Sometimes the researcher is interested in testing a specific difference in the means other than 0. And so when you were going through your example a while ago, I hope that you pulled out your formula card. I hope that you noted that you used this formula. But this one, the mu sub 1 minus mu sub 2, was turning out 0 every time because there was no difference. But here, suppose that we want something other than 0. For example, here she might have hypothesized that the nursing students at a community college are, on average, 3.2 years older than those at a university. And so in this case, remember they let mu sub 1 be the community college, and then y sub 2, focus here, mu sub 1 represented the community college mean, mu sub 2 represented the university mean. So they're saying they think this one, whatever it is, minus the other one, is going to be a positive 3.2. Then we have to look here and say, well, is it this? Is it greater than this? Remember, our null is always going to be our equals one. And then our alternative, our alternate hypothesis, is going to be representing what's going on. And we are saying, oh, look, we think it's going to be more than, based on versus the null and the alternative. And so now we're looking at a different scenario, the formula for, oh my gosh, the formula for the z-test is still blah, 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 where mu sub 1 and mu sub 2 is the hypothesized difference or expected value. But in this case, our difference is going to be 3.2 for our null. So this moves us in to confidence intervals. Confidence intervals for the difference between two means can also be found. And if you go back and look at your formula card, here's where we were comparing two means in the front end of this 9.2. And now we're going to be looking at confidence interval. Remember, it's really important to note what the question looks like to be able to decipher which formula you're going to use on the test. And so here's a huge one that we're talking about, confidence intervals of two means, not just one, like what we did in all of Chapter 8. Confidence intervals can be found when you are hypothesizing a difference of 0 if the confidence interval contains 0. Whoa, 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 whoa. When you are hypothesizing a difference of 0 if the confidence interval contains 0. This is huge. Then the null hypothesis is not rejected. We need to know what to do on our decision. Do we not reject? What do we do? If the confidence interval, where am I? If the confidence interval contains, I am so sorry. I am trying to read on two different screens, so let me start this whole part over. When you are hypothesizing a difference of 0, if the confidence interval contains 0, if it's in there, if it's inside the good parts, we do not reject the null hypothesis. However, if the confidence interval does not contain 0, it's out in those badlands, no man's land, remember me talking about those, then the null hypothesis is rejected. Confidence intervals for the difference between two means can be found by using, oh my gosh. Remember a while ago when I said it's going to be kind of bigger and a little bit uglier? No big deal though. Keep looking at it, let's break it down, and let's see the pieces and parts before we even tackle this thing. I'm going to cover up this side, and I'm going to cover up this side. Oh, well, looky there. That's just the difference of our means. Okay, that's not bad at all. Then I'm going to show this part. Let's see if I can do it. I might have to rip apart some of this. Let's see what happens. Stick it right there. When I look at these two parts, looky, looky, they are identical. And we've had pieces like this before where we had to do a pretty ugly calculation but we only had to do it once and then use it in both places. Oh, well, this isn't bad. It's got a sigma, it's got my n, I can do the square key, I can divide, I can add. I'm going to have to use some parentheses in this, but that's not a big deal. I'm going to need to square root it, but don't forget, out front we're going to need to multiply it by the z sub alpha over 2. Okay, this doesn't look bad at all, looking pretty good here. And then whatever we get in all of that stuff, we're going to need to add it to the means, to the difference of the means. Oh, if I add it over here, I wonder, and I can't pick it up, what I'll do over here. Well, you probably guessed it. Over here, we'll take the difference and subtract. Over here, we'll take the same difference and add. Oh, well, I'm going to end up finding out what this difference is and writing it down. I'm going to find out what this pretty big old thing is, and I'm going to write it down on both sides, and then literally it's added on one side, subtracted on the other, and we are done. So what it's asking on this question, and by the way, this formula is right here. It's not hideous. It looks hideous, but there are all our little pieces and our parts. They're all right there. Here we are. What it's asking us to do is find the 95%, here are my key words, confidence interval for the difference between, so it's not just any old confidence interval, it's the one that's the difference between the means. That means I need to go pick up chapter 9, I need to go pick up this huge formula, and I need to be disciplined enough to write down the whole formula. And they want us to do this for what we looked at in example 9-1. So what I did is I already went back on 9-1 and pulled the pieces and parts to this page. I pulled our sample mean, I pulled our sigmas, I pulled our z sub alpha over 2, and I pulled our sample sizes, and those are the same. The only thing I did on this is I didn't pull it, I don't think that was it on the other problem. I went to the 95 and grabbed it off of here, because on our two-tail, 95%, if I go down to the bottom, you see my 1.96. You know, we have to have our last lesson with a shiny screen, just like we had in class. And here, I just noted it's plus or minus since I'm dealing with a two-tail. And so I would write down this entire formula. So this is a great place to hit stop or pause on the video and go ahead and write down this whole formula, talking yourself through all of the pieces and the parts and what is going on here on all of the stuff. Then when you get through writing down the formula, let's plug in the pieces and parts, and I don't think I'm going to be able to have all of this on the same screen, so I'll just scoot up and down. I'm going to grab my 39.6, I'm going to put it here and here. I'm going to go grab my 35.4, and I'm going to put my 35 and 4/10 here and here. I've got my z sub alpha over 2. I'm going to put my -1, my +1, and really I should just put 1 plus 9.6 because it'll take care of the minus and the plus here. And then I've got all of this mess going on underneath both of these square roots. And so what's going on underneath there, I go grab a sigma and my other sigma, put them here, put it here, put it here, put it here. And then we found out that our sample size goes here, 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 and here. So this is pretty gross looking. And we already talked about, I'm going to do this thing once because it's already over here, and I'm going to double check myself, make sure it's correct, and I'm just going to use that in a minute. But before I do, I'm going to go ahead and punch the big ugly one here. And so looking at the big ugly one, you just got to practice with your calculator and you got to make it work. And so when I'm looking here, I like to start inside, and I'm going to start inside and still try to refocus this thing again, and maybe that'll help. I'm going to start right here, and I'm going to do 6.3, and I'm going to square it. I'm going to divide it by 35, but if I don't have parentheses around it, I need to go ahead and tell it equals. I'm done with that fraction. I'm going to add in, I'm going to go ahead and use parentheses now because I've got to be smarter than my calculator. And I'm going to do this, the 5.8 squared, divide it by the 35 and close parentheses. I'm done with that fraction, but I'm going to hit equals to say I am done underneath my square root. So now I'll take the square root, and on this particular one I have to do a second, and then second to go grab my answer, which is I go down here and punch the negative sign, and that grabs my answer. I don't have to close the parentheses. I've found that I don't have to. When I hit equals, that is the square root of all of this mess, but wait, there's more. I have to multiply by the 1.96, and I'm getting about 2.837, so we can round it wherever. Let's see where they rounded to. And my they left it at a 2.8. So we're going to minus a 2.8 and add a 2.8, and boy, this thing got pretty real fast. But I want to go ahead and do this subtraction, either in my mind or on my calculator. I'll do the 39 6/10 minus 35 4/10, and I get 4 2/10. There it is, there it is. And we are almost done. It's like once we get through this beast, we have tamed the beast at this point. So a quick addition and a quick subtraction, and we find that the difference of our means is, this confidence interval is between 1.4 and 7.0. I want to run right back up here where I had to read it, I don't know, 3 or 4 times. If the confidence interval contains 0, the null hypothesis is not rejected. So between $1.40 and $7 is 0 money in between $1.40 and $7. No, it's not. So it is not between, and if it, then the next part says, if it does not contain 0, here's our answer, the null hypothesis is rejected. And so to finish this up, and then they just show what they got on a TI-84, since the confidence interval does not, y'all just saw that, 0's over here, not in between. The decision is to reject the null hypothesis that agrees with the previous result, and as you saw on the earlier page, when you were watching the video, we are still using this traditional method. This traditional method is still on your card, and you probably wrote the chart from page 417 down here, and so you would know exactly what to go write. Sorry, I hope that's not making loud on the video. What you would go write from here, but then over here we get to say that we do, where did I go again? Since the confidence interval does not contain 0, the decision is to reject the null hypothesis. So make sure you're making good notes in your own notebooks, but that you're also making good notes on the formula card to know when you're going to use the pieces and parts and when you're not, and where you need to go to find the different formulas. This is it. This is all we're doing in this semester. So congratulations, celebrate, do a happy dance. We are finished with 9.2.